Welcome to another video for General Science. In this video, we're going to be discussing the concept of power. So power is an equation that's a function of work over time. So if you remember from the previous video, we defined work as a product of force times distance. Okay? So work over time and the P, capital P for power. So on some of the equations, you might be given force and a distance as opposed to just work, so watch out for that. Okay, so work over time. So let's take a look at this ratio of work over time. Let's say, like we've been discussing with the other ratios in our other videos, the amount of work increases, okay, but the time remains constant. So if my numerator increases, but my denominator remains constant, then that means that the overall number increases, or in this case, the amount of power increases. Now, what if our time increases? So the amount of time it takes to complete work increases, but our work remains constant. That means the denominator is increasing in size and the numerator is staying constant. So as the denominator gets bigger, the number approaches zero or it decreases. So the amount of power that I'm applying to a job is decreasing. So one way to look at this, so let's say I need to move these 9 boxes into my budget van I'm moving. So of course I'm going to need force, and there's going to be a distance that's going to be covered. So that's force times distance, work. Now here's two scenarios. The first scenario is the amount of work that I need to move these boxes, and it takes me 1 hour to do that amount of work, my force times distance. Okay, and the other scenario, it takes me 3 hours to do the same amount of work. I have the same number of boxes and I need to cover the same distance and the same force, but it takes me longer. So in which of these cases would more power have been applied? Well, if it took me an hour compared to 3 hours, that means I applied more power to my first scenario. So that's greater power. Okay, notice how my numerator on the left is smaller than the numerator on the right, which means my overall number is bigger on the right. That means more power. So I used more power. Now notice also that the amount of work is the exact same. I did the same work, the same number of boxes, the same amount of force, but the distance was the same. It was just the time that I used was different. In one I was a little more proactive, I applied more power, and in the other one I was a little bit more lazy and maybe I rested more in between. But either way, hopefully this analogy works out for you. So let's say I push a car with a force of 10,000 newtons for 20 meters. Okay, so I'm applying amount of work, force times distance, and let's say I do that over a specific time. So my force, which is 10,000 times my distance, okay, is 200,000 joules. Remember work, the unit for work is joules. And let's say I do this over 40 seconds. So how much power am I applying? So that's 200,000 divided by 40 is 5,000 joules per second. Okay, and the unit for work, or for power I mean, is watts, which is a capital W, watts. Okay, so I've done 5,000 watts of power. Now let's compare that to, let's say, what if the Hulk did the same amount of work? Same car, same distance, but it took him 4 seconds, so he threw it. Okay, so that's 200,000 joules over 4 seconds. Okay, so he threw the car. It took him 4 seconds to get to cover 20 meters, whereas for me, pushing it took me 40 seconds. That means he applied 50,000 watts as opposed to my 5,000 watts. So the Hulk has a lot more power than I do. And of course, the Hulk is fictional. So yes, the Hulk creates more power. Okay, because the amount of time that is required for him to move that vehicle over 20 meters is much less than your average human. Alright, so let's take a look at a problem that you'll see in your book. Okay, so you have a 575 Newton pillar. It is being lifted up straight up a distance of 20 meters by a cable attached to a motor. So I have a force and I have a distance, and the box moves with a constant velocity, and the job is done in 10 seconds. So there's my T. So what is the power that is developed by the motor in watts? So again, I moved it up 20 meters, my distance. So my power equals W over T, and remember my W can equal F times D. So now I plug in my units, 575 and 20, into my equation over T, which is 10 seconds. And so now it's just a matter of plugging and chugging. So now I just got to do the arithmetic on my calculator or mental math, and I find that I do 1,150 watts of power, or the motor does 1,150 watts of power. Okay. Well, I hope this helped you out. That covers power in the book, and good luck in your studying.